Okay, this is a video to pretty much directly to Casino McCool to answer this whole issue. He says that I have an artificial bias um, towards rational numbers when I did my videos on why irrational numbers imply approximation even in pure mathematics is a requirement just of nature. Even in pure mathematics, there's an element of approximation. And he's denying that. He's saying when we draw square root of 2 that we really do know exactly what it is. And you could have a logarithmic scale and that's exactly 1/2 unit in the logarithmic scale. And that for me to prefer rational scales with rational numbers is artificial. And I don't think so. I think that you, Casino, are adopting too much of the mathematical framework. And the mathematical, for the purposes of the thought experiment sort of involved here. The mathematical framework doesn't have any room for intentionality. It doesn't have room for time. Things just are the way they are. Whereas, I'm talking about humans where we'd have to measure and interact with these things. So it's not so much that I want to take somebody who is good at mathematics, such as yourself, and therefore has a good mathematical, perspective for doing math. We have to think more of the real world with human beings and modify the real world into this mathematical world. In other words, if I have a length, it could be something flexible, like a string. And, here's the length of the string. It's this long. That's 1 unit, how do I get 2 from this kind of thing? Because I'm not counting, discrete objects. Well, it's a string. I can bend it in half and then mark this point here. When I straighten it up again, it's got a little mark right in the middle. And the point of saying we were in a mathematical universe is just to say that even if we could mark that point exactly, so when we folded it, we knew the ends were exactly together, something we can't do in reality. Even if we did do that, then we'd still have this problem of certain marks we can't make on there, specifically the diagonal of a square. We could not mark anywhere on there that is that point of the diagonality of the square. So the thing I wanted to debate as a focus is my idea of why a measuring device, we'll use space, but really any measuring device, that a measuring device over space, let's say, or time, is going to have to use rational markings. Okay, and I take this as an empirical beginning where in order to see the length of something in some measure, you have to have this ruler. It could be a unit of any size of your choosing. And you have to put that in the same sense experience as the object. They have to be in the same image. And that's how you compare them. You then see which, where does the object you're measuring, how does it mark up to your measure? And to do that, often we do make marks on the measure so we know that it's a half or a third or anything. And as I'm trying to tell you, I have a way to make those marks by using a string as a measure, bending it over, marking. You can fold it as many times as you want. And so you can mark it in any time. You can fold it in half, and then you can, fold the halves in thirds, and you can divide that out however you want, in whatever order. And no matter what you do by this folding technique, you'll never get an irrational marking on that. So, and that's the only way I'm proposing. So you want another way to create a measuring stick then tell me, how do you get a measuring stick with a square root of 2 marker in there? No, you can't just divine it. You have to figure out where to put it on that string. If you calculate the limit of pi or the square root of 2 that'll define that unit, you'd have to do it forever. You would never find out through that method where to mark it on the string. Is there a folding method or something? You can't just tell me, well, put the string into a logarithmic space, because that transformation to a logarithmic space is what introduces the irrationality. So you can't just hide it in a function and say, well, magically, if you could do that. Well, because you can't do that. When we're making calculations, we're stuck with these empirical methods, even if we, idealize the physical world into one where we could get exact measures, which we can't for other reasons, many other reasons that I think we agree on. That's all I'm saying. Even if we assume, okay, you can get those measures, and you're in the mathematical world, you'll still never be able to actually use them or interact with them. So it all comes down to, if you agree with me, or if you could think of another way to make a measuring tape that can create the square root of 2. That isn't just, you know, just something trivial like, you just put it right there. You magically know where. No. I told you something like folding a string in half, so I can get all the rational numbers with my folding technique. How are you going to get the irrational number? As a marking. Not just a symbol, but as a mark on a measure. Can you have a measuring stick and put a mark right at square root of 2? Is that possible? Because I don't think so. I think what you can do is you can show me two rational marks on there, and you can say the square root of 2 is in between there. But that's the thing. No matter what you do, since you have to tell me where the square root of 2 is in rational terms, you'll have to tell me it's in this interval. So I relate the whole spirit to calculus and why intervals are actually more fundamental and real than numbers. Because in the mathematical space, the number 2 is an exact number. You don't need an interval. But the irrational numbers, you need an interval. But the whole numbers, the rational numbers, you don't need an interval. You can say exactly where it is. In real life, we find that even whole numbers like 2 are more like the irrational than they are the rational, because you'll never measure 2 exactly. You'll be able to say, well, I measured the height between 2 and 2.1, somewhere in there, because of the error. And that's what I'm saying. I'm saying that in mathematics we find that we have an area, surprisingly enough, even in mathematics, starting from exactly known numbers, that you still get these interval numbers where you can never exactly know them. You can only interval know them. You can sort of get a net around them, but you can't pin them down exactly. So that's my explanation again, but it's supposed to be focused on this question of how would you make a measuring stick? Starting from the fact that you have to have the measuring stick and the thing you're measuring in the same image. You're going to compare them, and you're going to compare to the markings. And how are you going to make a marking at square root of 2? Okay, something as tangible and as, that takes intentionality into account. You can't just say, well, poof, it's this thing. You can't say, well, I would calculate it by doing something for infinity. If a limit converges on a number like 2, that's one thing. But when a limit converges on something irrational, that's another thing entirely. So in one case you can exhaust the complexity, in another you can't. So yeah, I think, and even, of course you can bring up that it doesn't really rely on this, because my question is focused on, am I right? Does a measuring stick have to have rational markings as I think? Okay, and if not, tell me how it could have irrational markings. And then a second thing would be whether or not that really impacts the whole argument the way I've said. If that really is like this evidence for skepticism in math or not. That would be separate. But the first thing is, can you make irrational marks on an idealized measuring stick?